All right. So we're going to be looking at the graphs of sine and cos. So obviously we've looked at when we go around the unit circle. So, and if we do one lap around the unit circle, it's 2 pi. So and you remember obviously these are the y-axis and the x-axis. So if we're going to look at first the sine graph, y equals sine. So because you are also good at your exact values now, let's fill in this table before we do the graph. So if we are at x is minus pi, you're going to tell me, this is for a sine graph, so tell me when we're at minus pi, so that means we've gone around this way, what value is sine here?
0.
Yeah, good. All right, what value, if we keep going backwards, if we're at negative pi on 2, what value would it be for sine?
1.
Yeah, good. And what about negative pi on 4? So we have to think about it. It's like saying pi on 4, which is, so pi on 4, if you want to remember it as 45 degrees. So remember, it is the square root of your left fingers over 2. So would you agree? But we're gone minus. So if we go minus pi on 4, we're down in here. Would the sign be positive or negative?
Negative.
Yeah, so it'll be negative root 2 on 2. What about, so we're sort of going backwards this way. What if we, we were at negative pi on 2. That's down here. That would be negative 1, wouldn't it? Yes? Do people agree with that? We wrote that one wrong? No? Yes?
Yeah, I think it's 1.
Yeah, it should be it should be negative 1, yes?
Yeah.
Yeah, okay. All right, what about when we're at 0? So if we still we're back here at our 0, what would the sine value be there? Here, it'd be 0, wouldn't it? Now we're at pi on 4, which is going to be positive 2 on 2. Then we're up here, which is going to be positive 1. Then over here at 0. Then we're down here at 3 pi on 2. So what are we going to be at? Negative 1. And then back to 2 pi, which would be 0. Then they're saying 5 pi on 2, which would be up here, which would be 1. And so on. And then 3 pi would be over here. So 0, 7 pi would be down there. 7 pi on 2, so that'd be negative 1. And then back to 4 pi, which should be 0. All right. So what we're going to see is, obviously, when we draw this graph, and we're going to have y versus x. So the x actually is the angle that we're talking about, yeah? So you might just, the angle is x. So when we say sine x, so when x is pi, y is 0. Okay, so, and then you can go through. So when we have x is 0, so x is 0, which would be here, we've got y is 0. So we've got a point there. So this point, I'm just going to draw that here. This point here is that point there. So what we see too, and then we would go along the x-axis. So we've got, say, pi on 4, then they had pi on 2, then they had pi, then they said 3 pi on 2, and so on, and they kept going up. They actually jumped a bit, so I might just do that. So if we popped these in, we saw that pi on 2, this one, was 1. So it was, say, if I put 1 up there, so it was like that. And pi on 4 was root 3, so it'd be like this. And then when we got back to pi, it was back to 0, okay? So if I'd actually spaced this out a little bit better, we would have had, anyway. So what we're going to,
This is all with the unit circle, yeah?
Yeah, so what it is that this is the angle. So this, the x is the angle. So see here, there's x. So the angle. So the x-axis is what the angle size is. So now when we go around the sine graph, we're going to see this. So when we get to pi on 2, we know it's 1. So in the end, we see that the graph, it ends up being this shape here. And you can see we're back at 0. This would be 2 pi. And you can see we're down at -1. So up here was +1. And we're down at -1 at pi.
Oh, yeah.
Yeah, 3 pi on... 3 pi on 2. Okay, so there's a sine graph. But what they actually did is they actually did the values going out on the negative part of the axis as well. So we can also see they went to -pi. So we can see that this graph went down and like that. And they went to the -pi that way. So we can see, and this is a bit hard on the thing, but our basic sine graph is going to be like that, where it starts on 0 and it will keep on going. Okay, now what we see here is you see one loop, or like one, this is like one loop of the circle. We call that a period. So on a basic sine graph, it takes 2 pi, it takes you 2 pi to get around the circle once. Okay, now we're going to see these graphs get transformed, but this is our basic. So remember, like when we do graphs and relations, like we were doing all that, we know we have to start off when we do our transformations, we have to know like this is a basic y equals x squared graph. Well, we need to know the basic sine graph, which is this blue one down here. All right, so let's have a look at a few of the notes here. So the graph, it repeats itself after 2 pi units. So we did see that. So when we had the axis, and we saw that it went up and down, and we got to 2 pi, and then if we kept going, it would do that, and we'd be back at 4 pi. We'd be back at the same spot again. So the function repeats itself regularly is called the period function, and the intervals between the repetitions called the period. So in this basic sine graph, the period is how long it takes to do one of those, one cycle of it, which is 2 pi in a basic one. Okay, now we look at the other thing we're going to look at is the maximum values of a basic sine graph. So if we've got a sine, you can see the highest value it gets to is 1, and the lowest value it gets to is -1. So, and that, what we call this distance in here, where we say from the 0, it says from 0 up to the highest point. So because it's 1, that's the amplitude. So this graph has an amplitude of 1. It peaks up 1, and it also peaks down 1, but at -1. All right. So when you see they write the function down here, they've written the graph. So we know f of x just means like another way of saying y. And when they say this, that's how long they want you to, how far they want you to go through the graph. So because they wanted me to go way back to -2 on pi, so they've drawn back there, and they want me to go up to 2 pi. So they might ask you to restrict, that's like restricting the domain. This is the domain that they want you to show. Okay, so that's that. All right, so a Cos graph is a little bit different, but here we've got a Cos graph. So if we go through, we know at 0, if you think of our unit circle, when we're at, so if the angle was 0, so our line would be here. Remember, cos is the x on this x-axis on the unit circle, so it's 1. So you can see when it's 0, the cos is 1 up there. And then when it goes, when it's up here at pi on 2, you can see the x value is 0, and that's why that's 0 there. And then we keep going around, and we see the -1 and that. So here, this is one cycle of the Cos graph. So the Cos graph looks like that, but it's still, has a period of 2 pi. So it takes 2 pi for it to do its full pattern. So if I kept going and went like that, we would be up here, it would be 4 pi up here, okay? And the amplitude is still 1 on a basic Cos graph. So we know it peaks up at 1 and its lowest point is 1. All right, so what we get is we're going to do transformations of this. So remember, the y equals sine x is going to be, or they might write sine angle, doesn't matter. Like, so they might write sine angle. Sometimes they put the x, sometimes they put that angle, theta. So we're going to have these basic graphs, and then we're going to move them around. So, and it's the same as all your other ones. So when we see this number here in front of the sign. So if, for example, I might have y equals 3 sine x. So we're multiplying a thing. That's the it's going to change the amplitude. So instead of peaking at 1, it will now peak at 3. So if I was drawing that graph, quickly drawing the sine graph, go up and down, this will be at 3 and this will be at -3. Okay, so there's the amplitude. That number changes the amplitude. Now, if you have a number in front of the x, so what I mean by that, I'll just draw a little. If I had y equals sine 2x, so it's a number in front of the angle. That, what it does is changes the period. So you can see here, it'll change the period. We know in a basic graph, the period is 2 pi. If you get this number in front of the x, what you need to do is you have to do 2 pi, because this is the normal, divide by that number. So over here, if I was working out the period for this one, I would say it is 2 pi divided by this number here, which is 2. So it's pi. So what that's saying is when you draw this graph, your sine graph, like that, instead of it taking 2 pi to get through, it actually does that in pi. So it squeezes the graph up. Okay, so it gets a bit squishier. And then this, if you look at this other value, if you have a value inside the bracket in here, that's like when it moves the graph left and right. So say I had, I'm going to give you an example. So y equals sine x, I'll make it a little bit easier. I might just make it minus pi. So what you would have is we'll have a normal graph. So I'll do the normal one in blue. So this would be the normal graph where it takes 2 pi. So that is y equals sine x. When you have this pink one, you're going to move, because it's got minus, this means it moves the graph to the right by pi. So what happens is, say this point is at 0, this point will now be over, you move it over by pi. So say there's pi. This is probably not the best one because it's actually going to just move it. It'll still look the same. Anyway, so this point moves to there and this point moves over to pi. Oh no, it'll look a little bit different. This point will move to here. So you can see what you have is the graph looks like that. Okay, so it would have changed. So it's moved it over. So it moves the pattern of it. And the final little number, so the same as in your other graphs, this would move it up and down. So if you had, I'll just draw one over here. If I had y equals sine x plus 3, what you're going to have is still the same sine graph, but except it's like it's going to start up on y equals 3 and it'll still amplitude of 1. So that means when it goes through, when you draw it, so say it'll look like this. whatever, that will still happen at 2 pi. So because it started at 3, when it peaks up 1, that'd be 4. And when it, sorry, I shouldn't have dropped it down that low. When it drops down, it'll be at 2. Oops. Sorry, got too squishy on the thing. So that's what that is. So we're going to look at doing all of that. But at the moment, the best way to do when you do graphs is to decide what your period is. So how long is it going to take to do one full cycle? And also work out the amplitude. So often they're going to ask you, I'll just rub those out, and we'll do them with you, what the amplitude or the period of these graphs are. So I just wrote that in. Remember, the number in front of the sign will tell you the amplitude. So in this first one here, I'm going to say it'll have an amplitude of 3. Now, when I try to work out the period of this graph, remember it's 2 pi, it's always this formula, 2 pi divided by n, and n's the number in front of x. So because this one's a 1, it'd be 2 pi divided by 1, so it's just 2 pi. So that one, we can see it's not different. So the next graph here, we've got an amplitude of 0.5, and its period, even though it's a cos is still got a period of 2 pi. So over n, there's n, so over 4. So you could simplify that to be pi and a half. So what's going to happen for that graph, if I just drew that cos graph down here? Okay, so it's got an amplitude of 0.5. So cos graphs start up here, okay? And it'll go down, it goes down like that and up to there. So this would be negative 0.5. And what we're saying is it takes pi on 2 to get through that cycle. So that means this bit, this lowest bit happens on, you could say pi on 4 and so on. All right. Okay, so let's keep going. So the amplitude of this one equals a half. Now the period, I'll just write that one up here. So the period is 2 pi divided by n. So here the number in front of x is a half, so I'm dividing by a half. When you divide by fractions, remember you times by the flip of it, so that's how it will look. So the period for this one actually ends up being 4 pi. So this like spaces out. It's like really wide. It'll take a long time. All right, I'm gonna ask someone. Zach, what's the amplitude of this one?
It's 2.5.
Awesome. And Daniel, what's the period?
2 pi over 3.
Yep, beautiful. So you just leave it like that. Good. Jack, what's the amplitude of this one? Jack's gone? A half. And what about the period? Why are you still there?
X on 4. Pi.
So you got to do 2. It's always 2 pi. And you divide by the number in front of that x, which is actually a quarter. So what happens? That's like the fraction. So we're going to times like that. We times by the flip. So what will that end up being? It'll be 8 pi. So this one here takes 8 pi for it to get through one cycle. So it's quite big. Okay. All right. Okay. Who else? I've got Alex. Alex, what's the amplitude of this one?
4.
Yeah, good. And what's its period? So the period is always, you do the formula, which is 2 pi divided by the number in front of the x, which is this guy here.
Oh, so it's just pi.
Yeah, beautiful. So it ends up being just pi. Awesome. Who else have I got? Elijah, what about this one? What's the amplitude of this one?
Sorry, Miss, but I had a question.
Yeah.
What's the period?
So the period.
What does that mean on the graph?
Yeah, that's okay. So what's the period? So we're saying when we draw one so say I draw one sine graph. So what I mean by that is I get through one pattern of it. Yeah? That one pattern of it is a period. So on a basic, if this was a basic sine graph, which means we haven't done any other thing to it, it takes us 2 pi to get around it. Okay? So this one, say if you've got a period of, I'll just draw it. If we've got a period of, say, pi, so that would be y equals sine 2x, yeah? That one will look like this. It will see this would be pi. So what it does is it goes up and down in pi. So see how it squashes in? It becomes narrower. Yeah, so that's what's happening. So it's a period is how long it takes to do one of its patterns. Yeah.
So one up and one down.
Yeah, so a sine graph is that one, and for a cos graph it'll look like that. Sorry, that was pretty bad, but yeah. Okay, that was cos. Okay, so let's just quickly finish these because I just want you to practice them because you need to know the periods and the amplitudes to be able to sketch it. So we want to get confident with that. That's why I wanted to do this first. All right, so the amplitude of this one, because there's only a 1 there, that's actually 1. And with the period, we have to remember that this is not this 3x minus pi on 4 it's been multiplied. If we want to get x by itself. So if I took x out, it'd be x minus pi on 4, and we would have divided that by 3. So I'm going to say that's 12. So if you did that, that's what you get. So here, this one's a little bit tricky. The period is actually 2 pi divided by that number there, 3. That one was a little bit harder. Okay, and this next one, the amplitude, it's still 4. It doesn't matter if it's negative. It will change the way the graph goes. So when we have, just to quickly, we'll go over more of this tomorrow, but when we have a negative y equals negative sine x, we start the other way, and it goes like that. Okay, the amplitude would still be the same because the amplitude is just the highest it gets to. So for this one, it's 4, and the period will be 2 pi divided by 12, which I can simplify to be pi on 6. So that one's really squashed in. That one's going to happen really quick. And then this last one, the amplitude equals a third, and here's the period is going to be 2 pi. Now the number in front of the x is actually pi on 6, so I'll still do the same. So this is when we have a fraction, so we times by the flip, and you can see they cross out and you end up with a period of 12. So what happens there, they can be practical applications, and it doesn't matter, there's no pi there, it'll just be, it's a number. So it takes, along the scale, it'll be number 12 for this graph to get through a full cycle. Yeah.